So let's start today. Question that we have on the Leetcode is 1472, and we are going to see this question. So today question is saying that design a browser history, and you have a browser of one tab, and where you start on the home page and you can visit another URL, get back in the history, number of steps, or move forward in the history, right? And history number of steps, you can say, right? So what is the implementation class, right? So there is a browser history class, and this class will contain some methods like you can say browser history, string back, and string forward. So these are the methods we have. So browser history, that will take a home page, it initializes the object with the home page of the browser, and visit method will visit an URL from the current you can say page, and it clear up all the forward history. And back will move steps into, you can say, in history. You can say back moves will go to the back in the history, and if you can only return x steps in the history, so x steps would be greater than x, so you will return only x steps. So return current URL after moving back in the history at most steps, right? And the forward method will do what? Move a step forward in the history if you can only forward x steps in the history, and steps will be greater than x, so you will forward only x steps. So return the current URL after forwarding in the history at most steps, right? So saying the visit method will do what? It will visit the from the current page, right? And it clear up all the forward history, right? So visit method will do what? It will visit the URL from the current page, and it will clear all the forward history. So back will do what? It will move to back in the history, and it can only return x steps in the history, right? And steps would be greater than x, so will return only x steps. So it will return current URL, and after moving the history at most x steps, right? The f steps, you can say. And forward will be what? It will forward in the history, and will only forward x steps in the history. X steps should be greater than x, so you will forward only x steps, right? So read at least 1 or 2 times, so you will understand the things, right? Some example we have given example, so let's read the example here. Okay, so example we have given browser history, so it will initialize the browser, then we will visit, then we are visiting. So three first on the browser history, right? We have put leetcode.com, let's suppose, then we have put it visit, you can say Leetcode, Google, Facebook, right? And after that we have called what? Going to back, right? Back, then we have called forward, then have visited, right? Then have forward, and then have gone back and back, you can say. Okay, so these are the steps we have, and these are the things we have, right? So as you can see, when we go to back, right, we have push you can say we have gone first to browse, to visit Leetcode, Google, Facebook, like this we have gone. Then we are getting back, one forward, right? And then we have visited this one, right? So this is 1 and 1, okay, that we are talking about here. And then what we have visited, we have 1, right? This LinkedIn, right? And then we have what? Forward 2, back 2, and 7, this one. So what it is saying, this is the output we have. So how the output is coming? So first of all, when we write browser history, right, what will happen? We'll add a Leetcode, we'll do Leetcode, and we'll do browser history. Then what will happen? We will visit, we are visiting first what? Google.com, then Facebook.com, and then YouTube.com. 3 things we are visiting, right? So first we'll go to back, right? So what will happen when we'll do back? So in back one will what? We will go to here, right? Because you are the YouTube.com, and we'll move to the Facebook.com, and then we return you can say Facebook.com, like that. Okay, when we'll do back again 1, then what will happen? We will go to Facebook, then Google, and then we'll Google. Okay, like this, because first backward we have gone here, then second backward will go here, and third will go here, like this. And similarly we'll do forward, so we'll go to from the Google, from here we will go to the Facebook.com, or the means like that we will move, right? And similarly we'll call to the visit again, so we will do visit again. And if we do forward, so we'll go what, linkedin.com 2 times we are going here, 2 times visiting forward. We cannot move forward any steps, you can say. You are in linkedin.com, so if you do the forward, you cannot move forward any steps, right? So if you'll do the backward too, so linkedin.com go to the facebook.com, and then it will go to the google.com, correct? And similarly, if you go to back 7, so what will happen, you are in the google.com, right? You are doing back, you can back only one step in the Leetcode. You'll go to the Leetcode, and then it will return to you can say Leetcode.com, right? So after these steps, what will happen, you will get some values, right? What result. So when we are visiting, we are not doing anything, it will turn null, right? So we are getting null. And when going to back, we will get a URL, right? When you are going back again, you will get nothing. When you are forwarding some visiting something like linkedin.com, and then we are going to what, forward, so you will get google.com like that. And if you do backward, you will get that one. And if you do back again, you will get linkedin.com, right? Like this. So I think you have understood. If not, don't worry, we'll discuss more there. This question has been asked in Leetcode, different top companies like Google's, Amazon, and Oracle. Like this company has been asked. So question is related to array, linked list, stack, design, you can say doubly linked list, and stream data. Okay, so some hints are given. 2 stacks we have given, and you can do faster with a different data structure. Okay, you can follow that. So there is multiple approach you can solve this one. 2 stacks, doubly linked list, and dynamic array. So we are going to understand 2 stack approach, and we need to store the history of you can say visited URL. The best data structure to store is a stack data structure, right? So the stack can only store the element in order where they given with the most recently given element, you can say that is a URL at the top of the stacks, right? And if you'll do the back operation, that can be implemented by popping the top element of the stack, correct? So let's understand this one. So let's assume this is our history stack, right? And this is our home page. We are going to the home, we have home page leetcode.com, and current you can say current is also Leetcode, right? So stack, while visiting visiting and doing a back operation, stack will remain like this one. Okay, now we are going to current leetcode.com. Now we are visiting google.com, right? So what will happen while visiting and doing a back operation, right? So the first when we are doing we are the homepage was leetcode.com. So current will now have Leetcode, and we will put into the stack, right? And we are visiting google.com, so we will push current into the history stack, and then we'll make the current with the new visited, right? So what will happen now, from the current we have put into stack. See, we are doing what, we are doing current, we will putting into what, stack here, right? So what will happen, now from the current it will gone, right? Now current is what, google.com. So next time if any stack will any other we are going to visit, like youtube.com we are going to visit, so what will happen, now current we have to put into stack, and then now we will visit youtube.com. So now from the current it will become now youtube.com. So once you are current is youtube.com next, so what will happen, the current already gone into, you can say, stack. Now we are visiting youtube.com to leetcode.com. So what will happen, current we are visiting youtube.com. Now we are going to visit Leetcode. So YouTube go into, you can say, stack now similarly. So in the stack you will getting like this one. So now current is what, leetcode.com. So we already have Leetcode into the history. So now we do back operation. If we'll do back operation here, so what will happen, current is leetcode.com. Now we do back operation. So we pop the top element of the history and mark it as a current. So we will first we will get what, current from the top, because from the stack, right, the top element we can remove, right? So for the top element will go, then this element will go, and then this element will go, right? Like this will go. So what will happen, first we will remove the top element, that is youtube.com. Then what will happen, now to implement the forward operation, you can again use another stack, right? And if you go back, right, we are talking about the forward operation. So if we go back, then we push the current URL into the future stack, right? And then we will use, because we do forward operation, right? And we do again want the most recently visited URL that we will store in the future data structure, right? the last in the order, you can say. So this could be a little hard to visualize, thus what we are providing the future animation to make sure that future and history stack will work, right? So let's assume this is a history that we are talking about, and this is our future stack, right? So current, let's suppose we have what, github.com, right? So first we will two stack is there, so we will do two back operation, right? That previously we have did like this one. See, when we are doing the back operation, one back operation will do what happened, the top element we will remove from here, right? So, and then it will become current operation is what, u2.com, right? So similarly what will happen, we have this stack leetcode.com, u2.com, history, Google, and leetcode.com, right? Then what will happen from the history stack, when we have the current is github.com, and we will do two back operation, right? So what happened, we are taking one element onto the current, right? And then we'll put onto the, you can say, future stack. So what happened, the top element we have removed from here, and then it will come now leetcode.com, and github.com will come onto the future stack, right? Another operation we'll do from the top element, we'll put onto the current, and we are doing the operation, right? Now leetcode.com and github.com will be on the future stack, and history will remain like this one. Okay, so what we'll do, we will do a forward operation now. So what will happen, these two are where our back operation, now we are going to do a forward operation. Now if we'll do the forward operation, this u2.com will go current, this is current. So what will happen, we will put onto the stack, and from here we will add onto the, you can say, here on the current. So actually what we are doing, current element we are putting onto history, and for the forward we are taking from the future, right? So what will happen, now history we are going to maintain, right? And from the future stack we will get the leetcode.com here, and then we will visit what, github.com. Then you can, because we are going to do forward, so you will get like this one. So now current we can put, we are visiting leetcode.com, right? So we will put onto the stack, and then we will visit the current. So we'll push current into the history, mark the current new visited URL, and clear the future stack, right? So now your future stack will be cleared because we are currently using what, github.com. Understood? So we can't go forward because operation are there, no element present into the future stack, right? We can't go forward. So if we'll do more forward, it will not go there, right? So what will happen, so in this approach we will use a string, you can say current string, to store the current URL, and we will use two stacks, that is a history and future that we have seen. So whenever we visit new URL, we will push the current URL into the history stack, and then we will fetch doing the back operations, right? So when we do back operation, right, whenever we do back operation, we store the URL popped into the you can say stack, that will be fetch during the forward operations, right? I think you have understood. If not, so let's go to the browser section and we'll try to implement this one. So purpose is just simple, we will use what, you can say, two stack we will use, right, like this, and we will maintain our you can say history stack and future stack we will update maintain, and then we will take one current string, we will take one current string, and this current string will maintain onto the stack and onto the future stack, both stack, right? So let's go to the browser section and we'll try to implement this one. What I'm talking about, we should take two things. The first, we are going to use stacks, right? So we'll take private and we'll take stack. I will take a stack, and this is we'll take a string type, right? Because these are URL, and that we can say history stack. This is history stack, and similarly we'll take another stack, that is our history, okay? And then another will use what, future stack. So two things we have taken, two stack we have to use, right? First you can say history, and another we will use future stack, right? So we will use the both operations, right? And we'll try to implement this one, right? Okay, so now what we will do, we will take one string, right? I'll take private and string, and this string is nothing but current string, you can say, right? Let's do like this, okay? we'll take current. So current string we have. Now what we will do, we have our browser history, so we will initialize our history, right? So we have history, and this is nothing but our new stack, and we'll do like this. Okay, and similarly we have what, you can say future. We have future stack, and this is like this. Okay, now what we will do, we have our now you have home page, right? Home page is the first visited URL, right? So to do that, we'll say current equal to home page, right? Because this is a first URL, right? First URL to visit. Okay, these things is done. Now what will happen, now you have a visit, right? So in the visit, what we will do, we will push into the history, right? So first of all, what we will do, we have history stack, so we'll take and we will do push. So the URL we will push, that is our, we have current, we'll put current. Then what we will do, we'll say current, now we will update as a URL, and then we will update our future stack. And this future stack will happen what, we will say new stack, like this. We need to delete all the entries from the future stack. Delete all URLs, right, from future. Okay, so we have to delete all the future stack. Now what we will do, this is done. Now what we should do, we will use back, right? So total steps we will pass. So what we will do, we'll write while loop, and we'll say these steps we have. So if the steps is greater than what, 0, and not in the history, right? Not into the, you can say history. If you don't have in the history stack, and if it's not empty, right? If it's not empty, then what we will do, we will push into the future. So future stack we have, in what we will do, push, we will add onto the first, onto the, you can say we will add the current one into the future stack. Then we will say current, will update our current, and current is nothing but our from, we will get from history. So we'll do pop, yeah, we'll do pop, and then reduce our steps. Okay, once this is done, right, we will return our, you can say current. Okay, now we have forward. So in the forward, we don't need to do anything. We'll use this, we have a steps, right? So we'll use like this only. Little changes we have to do, like see, first we have the number of steps we have, and we'll check onto the history. If future so future, right, future stack, from future, on the future stack we'll check this one. If future stack is not empty, then take onto the history, right? This is our history. So the history stack dot push will do, will put into current, we'll put the current onto the history, and then from the history, from the future, right, we will have our future. So the future stack will remove and then add onto the stack. Just we'll do like backward and forward, right, and then we will return our current. So just opposite you have to do, like we are initially while doing back, right, what we're checking from the future stack we are putting into the future stack, and when you're going to the back current, we are updating current from what, the history, have the pop element, will do pop, and then we'll update our history. Similarly, while we are doing the forward, we are pushing onto the history, and we are removing from the future stack, right, and then we are reducing our steps. And while we are doing you guys visit, what we are doing, we will put all the things into the history, so that we will have our history. And future stack we have to do what, delete all URLs, right? So these all, I think you understood. If you have any doubt, you can ping me in the comment box. Okay, so let me run this one. Yeah, this is working. So if you'll talk about the complexity, right, so let me go here. So you can see, let's assume that if we have total a visit, right, of n visit, right, let's suppose I'm talking about here. So if we have total n visit, okay, of the URL, and we are doing m number of steps, right, so let's suppose n is a number of URL, right, number of URLs, you can say number of URL to visit, and if we have m is the number of, you can say steps, right, to go forward, you can say go forward, and or you can say or you can say back, go forward or back. And if we have L is the length of, you can say URL of current string, then what will happen, we are visiting all the URL, right, and we are using what, we are pushing the URL onto the history, and then that URL we are going to the current, right, and we are clearing the future. All these operations will take, because they are just doing a stack, right, so it will take you can say O of 1 as a time complexity. Okay, and in the worst case, right, all the calls visit URL will take O of 1. Okay, similarly, if we'll do back operation, we are talking about to visit, right, and if we are going to back forward steps, right, so those two operations will take m step, right, so you can say, or you can say we are removing from the stack, that might be take n element in init. So in the worst case, what will happen, if we'll talk about the complexity, right, so in the worst case, so TC will become what, O of, you can say, will take a minimum between m and n, right, because see, we have m steps we have, and all the steps we will do either two operations, that is back and forward operations, right, and which one is minimum, we will consider that one, and that is all we have for the time complexity. And if we'll talk about the space complexity, right, space complexity, so space complexity will take the length of its, so you can say steps, right, so we are taking O of n as just this one, so we just have to multiply with length. So that's all I have for today. So if you like this video, please hit subscribe, so that you will get more videos like this. Thank you so much, guys, and please subscribe for more videos like this. Thank you. Please like this video.